lecture, we're going to talk about solutions, how we define solutions quantitatively using concentration units. Now, water, and most of the time when we see water, water is really a solution that we call water. For example, even forms of water that you would think would be pure, such as bottled water or tap water, the water is actually the solvent within a solution. And this is a type of bottled water, and this is just tap water, and you can see some different concentrations of the components in these two different types of water. And the unit here to express the concentration is milligrams of the component per liter of solution, which is mostly water, obviously. And you can see that there's calcium, magnesium, sodium in tap water, silica in the Evian bottled water, and then some anions as well. So you can see there's different concentrations of the different components. So this is why we consider water to be, a solution really, because it's containing something. So we want to take a closer look in this lecture about how we define the solutions and what types of concentration units we use, just so we can have a more critical discussion of water as we move along in this unit. So we're going to take a little sidestep here and talk in detail about some common concentration units that are used to describe different solutions. Let's make sure we're all on the same page as far as the language that we use to describe these solutions. Now, a solution is just a type of a mixture. It's a special type of a mixture. It's a special type of mixture called a homogeneous mixture of two or more substances. And a homogeneous mixture is when the components are evenly distributed throughout. And what that means is if you sample the solution at one point in your sampling device, you should get the same concentration of components as if you sampled another. So it's evenly mixed mixture, homogeneous mixture. And the solute, when we're talking about solutions, is the component that's present in the least amount, and the solvent is in the greater amount. And you can have one or more solutes in a solvent. And an aqueous solution in particular is where water is the solvent. So we're going to be talking about aqueous solutions here because we're talking about water and the different types of things that will dissolve in water and the concentrations of those things. So again, a solution is just a special type of mixture called a homogeneous mixture. And remember, you define the mixture by its components and the concentration of the components. And I want you to remember when we discussed early on last semester the mixture we call air. Air is also a homogeneous mixture. And remember that the way we think about air is based on the components, and depending on where you are, that mixture is going to, air is going to be defined differently. If you're in a very dry place, there's going to be 0 or very low concentration of water in your air. If you're in a humid place, it can go all the way up to 4% water in your air. We could even, like, to make an analogous situation here, where water is the solvent for all these aqueous solutions, we could say nitrogen is the solvent in air, because nitrogen is the component that we have the most of. And then the pollutants, we would just have very, very tiny amounts of them, on the order of parts per million or parts per billion, if you'll remember. So we defined air based on its components, and the same thing is true now for water. Normally, water is going to exist as in a solution with some minor components, depending on where you sample your water from. The only time you're going to have pure water, just water, and the only thing you have is H2O, is if you have very, very carefully purified it. And typically pure water, we would say, would undergo distillation and deionization, two different processes. It's very difficult to do. But water, H2O, pure water is hard to come by. Most of the time, water is existing as a solution where it is the solvent.